I'm Anil Kumar. Welcome to my series on trigonometry. We'll discuss 3D solids, three-dimensional solids in this particular video. We'll begin with the very basic question, which is question number one here. Draw a rectangular pyramid ABCDE with base ABCD. Name all the edges, name all the faces, explain how you can find the angle between the edge AE and the base, and D is explain how you can find the angle between the face EBC and the edge BC. I'll begin with the basic concept of what is 3D, and from there we'll pick up this particular topic. Now, as you know, 1D means one dimensional. So 1D means one dimension. When I say one dimension, then in that case, one dimension is that of a length. It is basically a straight line, right? So straight line, and in a straight line, it can extend to both the sides. However, we can always have a part of it, which is called a segment, and we say, well, this is the segment whose length is L. And that becomes the dimension which we talk about. So that is one dimension. Now, when we say 2D, in that case, we are talking about two dimensions. Now, when I say two dimensions, how do I represent that? Now, two dimensions are normally represented in the form of a coordinate plane. Now, this is represented on a number line, right? So, one dimension is represented on a number line. For two dimensions, we have a coordinate plane in which we can represent two dimensions. And also, we could make 2D figures, which are kind of rectangle, correct? So on two dimension, I could have length and width, for example. So I could make something like this and say this is my rectangle whose dimensions are length L and width W. So we get two dimensions here, length and width. We could write 2 points, length and width, on a coordinate plane to represent the two dimensions. So coordinate planes, as shown here, will be used for two dimensions, and as earlier I have shown a number line here which is for one dimension. Is that clear to you? So number line is for one dimension and coordinate plane is for two dimension. Now for three dimensions, we need to extend our coordinate plane. So we have x, y, and z axis. So we have x-axis. Um, Actually, the x-axis is normally shown in this direction. X, y, and z is shown upward. So we have a coordinate plane now, which is three-dimensional. So these are x, y, and z axis. Each axis is orthodiagonal, that means at perpendicular, right? So these are all perpendicular to one another, which we'll be showing in the form of right angles, which I have shown here. So we say that this is a plane. This is a plane which is a YZ plane. And here what we have is XY plane, right? So this is XY plane. And on that side, we have XZ plane. So moving from one dimension to two dimension to three dimensions, now we all of a sudden talk about planes. Do you understand the point now, right? So in one dimension, we were only looking into lines where you could find the length from, let's say, 0, how far you are. In two dimensions, we could have two quadrants, which is L and W, or X and Y in general. And in three dimensions, we have 3 points. And as you can see here, in three dimension, we introduced two: the concept of lines, the concept of planes, and these two-dimensional figures will be termed as faces. So what we do here is, when we talk about three-dimensional figures, in that case, we have concept of lines, which are one-dimensional. Then we have faces, and we have planes. So these three terms, all three of them will be introduced one by one. Now coming back to the question, we say draw a rectangular prism and then name the edges, the faces, and the angles between the edges and base. And how will you explain angle? How will you find the angle between the face and the edge? Now I hope with this concept, let's get into the real question which was being asked. So now we'll begin with to draw a pyramid ABCDE with base ABCD. Now ABCD is a rectangle. So as I had shown to you a 3D figure, let's get back to that figure once again. So you see this X and Y plane. X and Y plane is like our paper now, right? The way it is being drawn is kind of like this. And then the height gives you the three dimension. And we are going to use the same principle to sketch the pyramid. So let's sketch the pyramid here. Let me use a light color to sketch the base first. So let us say that the base is a rectangle ABCD. So I'll sketch this. This is my base. See how I'm drawing the line. Now this is the base of the rectangle, which is right on our paper, right? So that is ABCD, the base of our pyramid. Let me label this as A, B, C, and D. Now we have to give it a height, and that height will then be connected to each point on this side, and that is how you're going to get the pyramid. So let's say this is the height. Now this will be the center point, and this point here will be connected to all the points. Let me use a different color here just to differentiate between the lines which are coming from this place and going to the vertices, right? So like this, we have these vertices. Do you see that? So that becomes a prism for you, a rectangular prism, correct? So this was kind of overlapping here, so I kind of moved it slightly away to give more clarity. Now, the question here is that we need to name all the edges. These straight lines are actually the edges. So let me name the vertex E and then we'll write down the edges. So first we have these four edges on the base itself, which are AB, BC, CD, and AD, right? So these are the four edges on the base, and then four from vertex. This is called the vertex to the base, which is EA, EB, AC, and ED. So these are the four edges which come from the vertex E to the base. So in all, we have 8 edges. Now let's talk about the faces. So we have one rectangular face, which is the base itself, correct? A, B, C, D. So we have a rectangular face, which is A, B, C, D. And then we have triangular faces, 4 of them, and we can name them as EAB, EBC, EDC, and EDA. So these are the 4 triangular faces. So we have 3 triangular faces and we have 4 triangular faces, and we have 1 rectangular face at the base. Now let's get to question number part C of question number 1, which is explain how can you find the angle between the edge AE and the base. So now let me highlight this AE. So AE is this edge which is coming from the vertex to the point E, right? And the angle to this base will be this angle. So we are now talking about this particular angle. Does it make sense to you? How do we find this angle? That is the question. It is also referred to the angle of elevation from A to the vertex. So this is also referred to as the angle of elevation. And it is to be noted that the, the angle here is a right angle. And now we have our solution, and that is if I extend this, it becomes the diagonal, correct? So the diagonals of a rectangle will meet at the midpoint, right? At the center. So to find the angle, we can use, let's say the angle is alpha here. So to find the angle, what can we do? We can write down that tan alpha is equal to E to O, let's say O is the center, over A to O, right? So now we can find the angle alpha as tan inverse of EO over AO. And normally these dimensions will be given to us. If AO is not given to us, you can always find AC square to be equal to AB square plus BC square. So that using the Pythagorean theorem, you can find AC, which is square root of AB square plus BC square. Correct? And then AO is half of AC. So that AO is half of AC, and that helps you to find the angle itself. So I hope part C is absolutely clear. So that is how you'll do part C. Now let's look into part D, which is explain how can you find the angle between the face and the edge BC. Now when we say base face and the edge BC, uh, then BC is this particular edge. Is it clear to you, right? And that is the face we're talking about. So how do you find this angle which a face makes with the base? To find this particular angle, what we do is we take the midpoint here, join the midpoint with the center, and this midpoint and the line from E to the midpoint M, this line lies in the face. So we are trying to find the angle between two planes. So we are trying to find, when we say the angle between face and edge, we're trying to find angle between two planes, right? So the face is one plane and the other plane is the base itself. And to figure this out, what we have done is that we have taken a midpoint, and of course that will be at right angles now. And then, sorry, this place is right angles, not that. Sorry, we have to find that angle. Uh, Let me write this as beta. So that is the angle beta which we need to find. And this height is at right angles. So we can now write that tan beta is equal to the opposite side EO, the height of this pyramid, times OM. And that is how you find the angle beta, where OM will be half of the length AB. Is that clear to you, right? So in one case we use OM, which is half, because these two are equal, and in the other case we use half of the diagonal AC. Is that clear to you? Now, once this is clear, we'll now take up examples and find the actual angles when the values are given to us. So I hope you have understood the basic concepts. And now let's begin with the example. We'll take up first an example with a cube and then with a rectangular prism. So question number 2 here is related to a cube shown on the right hand side. A cube is shown with each side equals to 10 centimeter long. Find the base diagonal AC. So A to C, so that is C for you. Let me write C here, A to C. Find the space diagonal AG. So AG, which goes through the space in between, is called the space diagonal AG. Calculate the angle GAC. So G to A to C. Calculate the angle GAC to three significant places. Now the question is triangle AHG a right triangle? Explain. So AHG, the triangle which we are referring to, is A, H, and G. So that is the triangle which we are referring to. Is it clear to you? Okay. Is this a right angle? Well, you have to figure this out and then answer the question. Find the angle AGH. So AGH. So basically we need to find this angle AGH, and we also need to find this angle A, which is GAC. So you can now pause the video. You already know the method of doing it. Let's figure this out. Okay, so part A is find the base diagonal AC. So AC is this particular diagonal. We can use the Pythagorean theorem to find. So we know AC square is equal to AB square plus BC square, which is 10 square, which is plus 10 square. You can take 10 outside, right? And then you get square root of 2. And that is what AC is when you square root it. Is that clear to you? So what I did was that I squared 200. So we have this as, you can say, 10 square outside, 1 plus 1, which is 2. And when you square root it, you get 10 square root 2. So that is a faster way of doing it. Perfect. So you know AC. Now find the space diagonal AG. To find AG, what are we going to do? Now we have to find A to G. Well, we know what AC is, and we also know that this is 10. Since it is a cube, all sides are equal, correct? So we can find the diagonal A to G. So clearly what we have is that AG square should be equal to AC square plus GC square, correct? So we are going to use this to find the value of AG. So let's write down AG. So AG square is equal to AC square, which is 10 square root 2 whole square, plus GC square, which is 10 squared. And clearly this, you can take 10 square again common. See the beauty of taking 10 square common. And then you get square of 2 plus 1, right? So 2 plus 1, and therefore you can now get AG as equal to 10 square root 3. Do you understand this method? I am taking a common factor since that is AG square. Now when you square root of 10 square is 10, and 2 plus 1 is 3, and square root of 3 is 3. So we get AG is 10 square root 3. Clear? So that's kind of important to understand. So we have done A and B, and C is calculate the angle GAC. Now to calculate the angle GAC, what we could do? Just take tan theta, right? So to calculate the angle GAC, we'll take tan theta, so which is this angle, right? So we say tan of, let's call this angle as theta. So we say tan theta as equal to GC over AC. Now that's a right triangle. So we get tan theta equals to GC over AC, which is G to C is 10 over A to C, we just found as 10 square root 2. And so we get tan theta equals to 1 over square root 2, or theta equals to tan inverse of 1 over square root 2. Correct? So let's use the calculator to find this angle. We'll find it in degrees. So we'll shift tan inverse of 1 divided by square root 2, and that is equal to 35.26. The question says You have to write this answer to three significant places. So we'll round it. And so we can get this answer as theta equals to 35.3 degrees. Is that clear to you? So that is how we can actually solve this question. Now we are left with the part D and E, which we are going to do in the next page. However, we'll also copy some values from here so that we don't have to redo them. So AC we figure out as 10 square root 2, and A to G is 10 square root 3. Simple as that. So let's go to the next page and work on this. So we found this was C to us and this is 10 to us. Okay. Now the question is, we have already done the first three parts. Triangle AHG. So let's look into this triangle AHG. So A, H and G. So that's a triangle in which now we are interested. So in this triangle, we know what AG is and what HG is. This is 10, right? It's a cube. So we know HG is equals to 10 and we know AG is 10 square root 3. Correct? So the second diagonal is square root 3. This diagonal, which is in the base, is square root 2. Now the first part of this question here is this triangle a right triangle? Well, clearly, we have two faces which are at right angles, so it is a right triangle. So the answer is yes. And the reason is that these two faces are at right triangle. So it is yes because faces are orthogonal. That is very important property. You don't really have to prove it by any other means. When two planes are perpendicular, then any line from one plane going through the other will be orthogonal, right? But we can also prove it. Let's see how. So here is a short proof. So let me prove it. So to prove it, let's find what AH is equal to. So AH will be equal to 10 square plus 10 square square root. Perfect, because both these sides are also 10 each, and we know that AH will be 10 square root of 2. Now clearly you can see that AG square is equal to AH square plus HG square, and that's the Pythagorean theorem, right? We found that AH square is 10 square root 2 whole square and HG square is 10 square, and definitely this is equal to what? It is equal to 10 square root 3 whole square. And so we know it is right angles. Does make sense to you? So that is clearly a right angle triangle. Now once you know that, then we can find this angle using tan ratio. So we need to find the angle AGH. So AGH is this angle. So when you look from this angle, then that is the opposite side and that is the adjacent side. So we have tan of angle AGH equals to the opposite side, which is 10 square root 2 over 10. Perfect. So which is square root of 2? So we have the angle AGH, which is equals to tan inverse of square root of 2. Now we can use calculator once again to find this. So we'll press shift tan inverse of square root of 2. And that gives us a value which is 54.73. 54.73. We're rounding to 3 decimal places again, so that is the answer for the angle. Is that clear to you? Perfect. So we have solved a cube and found the angles. Now we'll take up a rectangular prism. Question number 3 here is rectangular prism. A rectangular box is shown. find plane diagonal AC, find space diagonal AG, find the angle GAC, show that the triangle AGH is a right triangle, and find the angle AGH. It's kind of repetition of what we just did with the cube. So I would like you to pause the video and solve this question. Perfect. Now here is my solution, which is find plane diagonal A to C. So let's figure out what A to C is. So we'll apply the Pythagorean theorem since we know that this is right angles, right? It is given to us. It's a right angle. And clearly, we can write what AC is. So AC square is equal to AB square plus BC square, which is 10 square plus 3 square, and which is 100 plus 9, which is 109. So AC is equals to square root of 109. So let's use calculator to find this value. So it is square root of 109, which is equal to, in decimals, 10.44. So we'll write this as 10.44. The second one is find space diagonal A to G. So this A to G, which is marked, we need to figure this out. So let's find this. So A to G is, again, Pythagorean theorem. AG square will be equals to AC square plus GC square. Now that is AC square is 109. We'll just square this number, and GC square is 16, right? So AG will be square root of 109 plus 16. So let's find this. So we have square root of 109 plus 16, and that is equal to 5 square root 5 is the exact value. And the approximate value will be 11.18, which we can write as 11.2. So we get these two values. Now, you need to find the angle GAC. So GAC is this angle which you need to find. So we'll again use tan ratios, correct? So we know that is right angle. Since we know that this is right angle, right? So we can use the tan ratio and find it out. So we have the tan ratio for angle GAC is equal to GC over AC, which is equal to GC is 4 and AC we just found as 10.44, right? So you could also write, let's say 10.44. So the angle GAC is tan inverse of 4 divided by 10.44. Is that clear to you? So let's find this out. We have tan inverse, shift tan inverse, that is, and we have 4 divided by 10.44. And what we get here is 20.96. You can check these answers, right? So I'm just calculating with the help of a calculator, and we get 20.96, which can be rounded to 21 degrees, right? So the angle here is 21 degrees. So we've done the first three parts. For the next two, let's go to the next page, which is show that this particular angle here is 90 degrees. So we will look into this particular triangle and we will show this is 90 degrees. You know this is 90 degrees because of perpendicular planes, right? And then you have to find the angle AGH. So AGH is the angle which is this angle. So you can find this angle. Now for that angle, you will need A to G. So let us see what the value of A to G is. And we'll use this value 5 square root 5. Okay. So let's move on to the next page. And let me write down A to G is 5 square root 5. Perfect. Now, so part we have already done the 3 here. Now we have to show that this particular triangle is a right angle triangle. Last time we did all the calculations. This time we are not doing a calculation. We are saying these two planes are perpendicular, right? So our reason is that the planes, which is EAHD, is perpendicular to HDCG. Is that clear to you? And that is the reason why we have angle H equals to 90 degrees, the one which is marked here. Is that clear to you, right? So that is how we have done this portion. It's a right angle. Now, let us find the angle AGH, that is this angle. Perfect. Let's find this angle now. So we have tan theta, which is tan of angle AGH, equals to the opposite side, which is AH, over the diagonal, which is A to G. Now AH is what? We have to find this out, right? 3 and 4 and 3. So that gives you 5. This is 4 square plus 3 square square root. And A to G, we calculated, was 5 square root 5. So this square is 5, 5 over 5 square root of 5. So we get 1 over square root of 5 here. That's easy. Now let's find what the angle AGH is. So angle AGH will be tan inverse of 1 over square root of 5, which is, let's again use the calculator to find this answer. Shift tan inverse of 1 divided by square root of 5, and that gives you as equal to 20.09, 24.09. So this gives you 24.09, which is approximately equal to 24.1 degrees. So we have again rounded to 3 significant figures, and the answer is 24.1 degrees. Perfect. Now let's take a short break, and after this break, we'll take up pyramids. So we have considered prisms in this part, and now after the break, we'll continue with pyramids. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that will be great. Thanks and all the best.